It is our pleasure to welcome Kanwarpreet Singh Khurana and Nitasha Rawat. Kanwarpreet is a lead consultant at Infosys, and Nitasha is a digital solution specialist also at Infosys. Kanwarpreet and Nitasha would be speaking on SRE, what does it imply as a tester? You can take a look at their video interview by checking out the link on the screen. Kanwarpreet and Nitasha, the stage is all yours. I would request you to share your screen now and start with the session.
Hi all. So just one confirmation. Are you able to see my screen?
Not yet, Anwar.
Yeah, we not the screen not, but we can see your video.
Yeah. Yes.
Now it's there, right?
Yes, not yet. Yeah.
Okay. So thanks for giving this an opportunity to speak about SRE. What does it imply as a tester? So before I start off, I just gone through some of the sessions because I just joined late this conference. Just before that, we have one of the session where we have a full stack engineering, where we are talking about that, and the last session, which was by Ajay, that is on our mindset and how the leader should be, right? So SRE, which I am just thinking of, like before we go that, I just want to highlight, might be relate all the questions, all the concepts which we had before, and so that you can relate all the concepts of SRE. So might be it's a new for some of the testers, and because it's not a new term which comes in our IT, but nowadays, because of you can say need of an hour, each and every organization need SRE. So I have Nitasha. I think she is on a call now. So Nitasha will be there along with me, and I will cover today. We will have this agenda, that like what is SRE and principles, why SRE we need, constructs of SRE, failure, and what to do. And we will little touch upon the chaos engineering, day life in SRE, and benefits or outcomes of SRE. So we will start with SRE. So what is SRE? So SRE is site reliability engineering. So it is a discipline, or you can say the principle, which we have to see how reliable our systems are and services and products. As we all know, even in one of the session, like we are now in our session, I suppose everything will be get shut down, right? So we have to see how this specific application or a product, as a Zoom as a product, is reliable. Are we able to get all the services, and how much availability we need? Because I have seen where one of the track is not working, we get an option to move to track 2. So this is something where an unexpected event happens in our production systems, and what exactly the precautions or the steps we need to take. So what happens if we are having a production issues in our on our regular basis and all the things? What will happen? Like our customers will get frustrated. Obviously, we lose our customers, and we don't have a customers don't reliable on our product, and it also damages our product image in the market. So that is the reason this term came up in our SRE. And SRE is a practice when creating a scalable and high reliable software systems. So it's just a practice, or you can say we all know about the DevOps. So SRE, in my thought process, like whatever I have an experience, SRE is just an abstract or extended class of our DevOps. So whatever we are doing in our closed systems, in isolated systems, so SRE is basically we are doing all the engineering, all the failures in our production systems, so that it should be taken care by our SRE engineers. So SRE team is responsible for the availability, latency, performance, efficiency, change management, monitoring, emergency responses, and capacity planning of resources. How we can do it? So we must be aware of all the different kind of events which can be come up in our system, which can be come up in our during our production, like how much turbulence will come up, right? So this is the main responsibilities of our SRE team to maintain. And we know that we in our IT systems, we are moving from waterfall to agile, then DevOps, and DevOps is giving the our product in the market faster way. And if we are doing all these things, definitely we need availability, and we can't make it in that way, like we are faster in the market, but availability and reliability is not there. So this is the main responsibilities of SRE. And if you see all the DevOps teams, which I have talking about, DevOps teams is going for a release speeds, and quality checks and stability is done by the operations teams. So all the three teams are working together, and it makes as a term as a SRE. And in one of the question I have seen, is SRE is same as a full stack quality engineering? So it might or might not be, and definitely you will get this answer in our next slides as well, because I have seen this question in our one of the last topic as well. So I will just explain that how we can relate SRE in our testing side. So around why SRE will.
Sorry, are you sharing the screen yet, or you are going to share? Because we can't see anything.
I'm sharing.
Yeah,
That's
yeah.
what I asked. Just give me a minute.
Correct. I am
That's
also not able to see.
Yes, yes.
sorry,
That's why I just
fine.
want to quick check, because you said you are going to share. So
Okay. Are you able to see my screen now?
Yeah, now it is
yes,
visible.
now it's visible.
Oh, sorry.
Thanks. Thanks.
That is the one, right, which we are talking about at production level, right? So
Okay.
so what all things we missed out, and how we need to test it. Sorry for that. And
I think you can click on hide as well, so that it is getting displayed in the screen. We thought you are just giving the overview of the what you're going to cover. Anyhow, thank you.
So this is the SRE. This is the slide which I think I missed out. So how all the three teams are working together: development team, QA teams, and operations team. And next is why SRE, why we need SRE. And we, as per the DevOps skills report, 22% of organizations have already adopted, and many of the big companies like Google, Netflix, all these companies are having their own internal products on SRE, which they're checking. And we also need a SRE skills, must-have skills, which we will talk about that, which all skills we need for being a SRE engineer. So what all constructs we are having for SRE? What makes our SRE as a term, or we can say the things which we can come together, which will say this is SRE and what we have to do. So always we are having service level agreements, like a service level indicator. So that is basically an indicator where we record or measure what kind of matrices which will impact our system, and on which we have to work to get the value, like matrices, like we are having a MTTR, where we have a meantime, then we have a MTBF, where we need to check, okay, fine, this is something is going wrong. And on those basis, on those basis of all the SLIs, we are creating as a SLO, that is a service level objective. What is the objective of that? We all know we want availability of our system, or reliability of system, but how much availability we're looking for? Is it something 90%, 99%, or 99.9%, where we have to decide with the team or a product team how exactly they are looking for? Because more availability means the more cost. So that's the reason where we have to find it out what exactly the numeric value we are looking for. And next we have a SLA. This is basic, you can say, a business contract between between two parties. Like if we are using a Google or AWS, if we see, we always have an agreement. Like if we are using EC2, how much time it would be there for availability, and if it is gone beyond that, what would be the charges, or what would be the compensation will be given by the service provider to the customer. So basically we are having these three terms we always use in SRE. Then we have a toil. As a being an automation tester or being in automation, we always say automation, but in SRE we say toil, where we are having a manual things or operations which we are doing on our daily basis. We have to automate that by using different availability of our tools and our different we can create our on the basis of a requirement on different layers like infra, application, or application layer. So we can do our automation so that we can have manual effort or manual events to perform. Like if I just give an example of at our infra level, where we have to go for a scalability from 1 to 100 of our systems, and then we have to come down. So we have some mechanism there. So it will definitely read out what all numbers we are giving, and definitely we are in our AWS, we are having we have a we can put the numbers, like if this kind of number of responses we are getting or traffic is there, so we can move from 50 to 100, and if the minimum number will come up again, it scale down. So this is kind of the automation we have to do, so that our system will never be down during our production. So it will reduce our cost of failure and shared ownership. So shared ownership is basically the ownership between all the teams, where we have a DevOps and along with that we have a site reliability engineer. So site reliability engineer is also a member of our product team, or you can say the agile team, so that they can work all together, so have and share their ownerships. So this is a way of working, SRE way of working. As basically we have a constructs of that where we have a technical capabilities and process capabilities, because we have, this is a mindset where we have to take all the people, mind, along with that the technology. And basically we have a capacity monitoring, like we in monitoring, like we have to see to monitor our servers and getting the logging, monitoring all, and while monitoring, if something is going wrong, alert system should work. So all these things are coming together, and we have a scalability, reliability, and one of the session we have say abilities in testing. So this is something, that's why I'm saying SRE is not a isolated part from testing. We can consider as a tester or an automation tester, as an advanced automation tester, as a SRE, who have to take care of everything, how reliable we are, how scalability we are having in our systems. So all come together, and how the ways of working, like operating model, ways of working, and governance, we all three are having how SRE team will operate within an organization. Then we have to maintain our different processes, like incident management. If some incident is coming, how it will move from one state to another, and how SRE engineer will see, okay, fine, this we can be able to take it up for our testing, and so that the same kind of issue will not come up. Release management, availability management, so all these processes are coming up in our SRE as a constructs. So these are basically a very wide one for each and everything. So I'm just giving a glimpses of that, how SRE constructs are there. So we are having a key pillars for our SRE, that is monitoring, alarming, and logging, which we are talking about, and reliability, how reliable our system is, and in our sub areas we are having self-healing capability. So we have to create the utilities, or we have to give the you can say steps to the system to self-heal once anything is coming up, it should self-heal, and it will take an action against any failure. So to do that in SRE, there is one term like we always say, like uh, failure should come once. One kind of failure should become once, so that we handle it, test it, and let the system take the decision when the same kind of failure is coming up. So there is no, you can say, uh, acceptance of having the same failure should come again. So that is the main responsibility, so that we have a reliable system. And next we have availability, like how much availability of the system we are looking for. As we all know that uh, uh, we are moving to cloud, and our architectures are changing from monolithic to microservices, and we have and most of the applications or systems are moving to uh, cloud, where we having availability zones, so that we can deploy our uh, applications across the globe. And we have to see if one of the availability zone will get down, how we can take it up the same application, so that our customer will not impact, and some of the processes which are going on, it will continue. So in this process, we are having a DR process, monitoring and logging, so that we just monitor our systems, and once we are getting any of the uh, failures, we get a log. What is the reason it is getting impacting? Might be a server get shut down, or might be we have done something like where our system gets stuck, like a database where we get some of the null values at a production, and our database comes down, so we can't be able to proceed with that, and related microservices will not work. So we have to see all these things, so that we can do our analysis on this. And next is scalability, which we are talking about. Auto scaling and auto scaling matrices. We have different matrices on which we can auto scale our systems from 50 to 100, and again 100 to 50. So it depends on that. So this is something we always thinking about, how scalable our systems would be there. And performance, we always do performance on the basis of our NFR, like performance testing, where we induce something, right? We have to see how our system will perform if we have a stress on our servers, and how we can do our load testing on our servers, and how our application will perform. So this is basically the performance we are doing. And capacity backup and restore, where we always go for a database backup if we are having a database corruption in our production systems. So how we taking our backup? Are we taking a backup on the same availability zone, or we are taking a backup from one to another availability zone? And even during in our in-house, or you can say uh, we are having on servers in our servers, so we can use at least a backup plan with us. So that is the one where SRE comes up. And we always have a zero touch backup and restore, where exactly our SRE team work on that, and make the system so reliable. So if any instance comes up, it will take a backup and restore automatically, and having a health checkup for our monitors, for and backup restore for that. If daily basis we are having a health check, and we getting reports on our dashboards. And the last one is security, access and deploy management, where we always see that we have a different kind of software patch policies are there. We are having if we see many of the times the patch comes up, and we just uh, uh, down our system to just induce as patch, and or we are having a different kind of policies where we just allow some of the users to work to use that patch, or once our patch is there, so that we can get a feedback from them. So all these on these basis of key pillars which we are talking about, we are having a different types of testing which we always do on on the basis of the requirement, right? Like reliability testing, some of the testings are very traditional testings which we do, like unit testing, integration system testing, and many of the testings which we do on production level, that is reliability testing, failure testing, which we have already discussed. It can be used at what if else analysis, where if something gets wrong, what would be our next action, so that we don't lose our systems, we don't lose our availability of our product in our at our product level, at our production. And next is our canary testing. I hope you heard about this term. That is when we allow, when we make a new feature or something, we want, like, some of the users just use that, and after that we get a feedback how that deployment goes on, so that we can go for a vast number of users. And next is our performance testing, which we always do in our infra level, scale up and scale down, database testing, usability testing, and the main testing which we always do, like chaos engineering, that is to test failure. So I will just come up with the next slide on chaos engineering, how we can perform that, so that before getting a turbulence, how we can be sure and confident our system is reliable. So for that one, we always do the chaos engineering, where we induce our failures on our stable product, to see the behavior of the product, what will happen. So failure. So we always talk about failure in our last slides, like failure is an action or a state not functioning. Like suppose my microservice is not working, and we have 5 microservices and one of the microservices is not working. So how we can make it work, or do we have any mechanism in the production to see how to have a backup of that microservice, or backup of our failure which will come up. So we have a different kind of failures. Application level, now we are working on cloud systems. We have a cloud service and infra level. In application level, we have seen like applications service failure or process failure and API failure, which I just discussed about, where we have a microservices or which is not working properly as expected. And sometimes we get in a cloud service where we have a service in our failure in our zone outage or region outage. As we know that in the AWS we are having one instance where the whole region outage was there. So how they do their testing so that their customers will not impact. So all these things are coming will come up as a part of our failure at our production level. Next, we are having the infra level, where VM get failure. We just having a VM and it is not working properly, and sometimes we are having a CPU burn, disk input output burn is there. We don't have a memory in our CPU in our VM. How we can make it to take an action at that time. So that is a horizontal we want, or we want a vertical kind of scale up during our infra failures. So all these are kind of failures which we always do the testing and do specific events to perform to know about what would be the action points for each and every failure. So moving to this chaos engineering, that is something we always do our experiments. So basically, chaos engineering is the experimenting approach on our system to see how much our system is confidence, to build our confidence on the system. And we see, like, yes, our system is confident, and how it will behave if any failure will come up, or unpredictable failure come up, and how it behave on that way. So we design our systems on that basis, and that are resilient to disruptions and failures. So we having a different processes to do that. That is, first one is hypothesis. Hypothesis, basically the process where we create an event, or we have to induce some failure on our stable system or stable product to see how it behave. And next is our real events or production, where we induce our real events by using different kind of tools. Like we have a gremlin is there, where we induce some of the events if any of the you can say uh, some injection should be there, SQL injection is there, or your system get off, or your server get off, how it will react. So we induce those kind of events using our specific tools. That is, Gremlin is available, Chaos Monkey is available, to see the continuity, to see the continuity, how if that failure will come up, how we can continue. First, we have to do the analysis of that. So once we do the analysis, we come up with the solution and we test it. And we test it on our very, you can say, the small set of testing to minimize our blast. So minimize our blast means, instead of having the whole system get turned off, how we reduce the blast. So we do in such a way, like start with smaller things, test it. If it is working fine, then we can take it up and take it as a solution, so that we can minimize our blast or minimize our failures at our production level. So all these things are going. And next we have a new insights like a proactive detection, preventive, and corrective. So all three terms are interrelated, where we have to take a proactive action. Means before going to the production, we see which all kind of failures might or might not come, and we just see that. And then we have a preventive. So we take a solution of that and make the correction, and so that our system will self-heal if some failures come up in our systems at the production level. So this is the chaos engineering, is one of the testing type we always do, and to remove our disaster recovery and to have our resilient systems. So these are the skill sets we always having as a site reliability engineer. So it goes from low, medium to high level, where we have a mandatory ones as well. So so that's the reason I said SRE is might or might not be a full stack quality engineering, where if you see most of the systems or tools are related to testing, like JMeter we are having, we have automation is there, Unix shell scripting. So it is a collection of all the skills which we always want, because I don't say all these are compulsory, but it depends on our requirement. If we are having a requirement of infra, then we definitely need a skill set of PowerShell scripting, and along with that Ansible and Terraform, so that we can work on that along. And if we want a DevOps part, where we are getting uh, where we have to create a solution for that specific area, then definitely we need a knowledge about Docker and Kubernetes, along with that the Python as a language, or Dynatrace, right? So all, and for monitoring we have a Dynatrace as well, and ServiceNow. So we all get together as a site. That's why I said site reliability engineer is not a isolated term or isolated role. It is a part of our agile or a product team, where all work together as a team. So these are the, if you want to take a screenshot of that, you can take it up, but it is a high level which I have seen, which we always need as a skill set to work as a site reliability engineer. So how the day in life of a SRE. So we just open our incidents which come up in our dashboard, and we just prioritize our tasks, and we will see how these tasks can be taken up, and we put on a priority basis, and then we just work on that task after analysis automation tasks, so that we can we can make it as a activity for us and utility. What would be the taking care of that, and then we have to join bridge for our incident triage, whatever incidents we are having, and dashboard and log analysis, and we just do our brainstorming on that, what exactly we getting an incident, and how we can make it as a reliable or a utility for to, so that it will come up with the solution or self-healing in our product. So this is the basically is a day in life we used to do, and we have to we discuss about the performance of our system, how our system is performing by taking out our reports from our dashboards on the basis of our matrices, and on the basis of our logs which we are having, and then we have to see exactly what will be the outcome of that. Are we getting high performance? Are we getting the systems which we are looking for, or the results we are looking for as an expected as coming up or not? So this is basically we have to do in our daily basis as a SRE, as an engineer. So last, that is our outcomes and benefits. I said like DevOps and SRE are very interrelated. We have a very thin line between SRE and DevOps. Like once we have adoption of our SRE in our systems, definitely we have a secure and reliable systems where self-healing capability is there, so that our system will take an action without having any manual interruption. And the second one is our embrace shift left approach of the delivery. So we know that we are moving shift left, we are doing our early testing, we are so that our product will be in the market at our early stages, but we have to see how efficient our system is also, right? So what we are doing with our chaos engineering, we are doing our experiments at our own level so that it will not come in our production. So it is not like that we just release our system, release our products, but we are not ensure how product is reliable. So we are doing our testing and experimenting before any of the turbulence or any of the failure will come up in our production, so that we can have that solution with us, and reduce toils through better monitoring and alerting. So we always have to reduce our manual effort with using our dashboards, and if something happen, how the alerting will work out for us. And then we have a managing operations as software to eliminate repetitive tasks. So that's what I said, like there is only one thing, failure should come once, the same kind of failure should come once, and we have to eliminate the repetitive tasks, so that it's not like that today it is coming and after 6 months the same failure will come up. So we have some solution for that, so that it will not come up with the repetition in our systems. And finding balance between innovation and reliability by monitoring error budgeting. That is one of the matrices which we always used for our as a part of our SLI and SLA, error by budgeting. And we have to see how innovative solution we are getting, so that we never reach out over SLO and breach over SLA between customer and the service provider. And last not the least, that is a cultural improvement. I said like SRE is a mindset. So we have to it gives us the cultural improvement where the mindset of our engineers.
I think we are almost end. It is 5:45.
So this is the last one. Okay. Yeah, this is the last one. Yeah. So the cultural improvement where engineers always gain an awareness and collaborate more effectively, and just like a DevOps team, and so that there will be no blame game on any of the team. So it gives us the more good environment where we have improvements in our skill set and our mindset as well. So this is the basically we are doing on SRE part and SRE testing. So thanks for joining, and if you have any questions, you can come up with that.
I think we already have one question. So
Yeah.
So how we can conduct SRE for SaaS products? Is there
In
any?
Salesforce.
Yeah.
So Salesforce is like we always have a internal teams, like we if we're talking about AWS, right? So they always have a internal teams to rectify. And if we are talking about a Salesforce or any SAP products, they always have the internal utilities or they have internal teams to work on that. What kind of event will if what kind of you can say action should be taken if we have this kind of failure. So they always work on that. It's like being a customer, I'm taking EC2, right? Or scalability. So we don't have a right to work on directly on performance basis of EC2. Their internal teams are working. They have own mechanisms to work on that. So definitely they are having their own teams to work on this. So I think basically we can work on applications, infra type of testing on SRE side.
Thank you, Kanwar. Thank you so much, Kanwarpreet, for such an insightful session. We really appreciate